So we have three functions that are graphed here. We have f of x graphed in this dotted magenta, we have g of x in this green, and then we have h of x in this dotted purple. And then we have three potential equations that could also be used to define functions. And what I want you to do is think about which of these equations match up to which of these function graphs. So let's go through them one by one. So this first one is reasonably straightforward. This is just a straight up quadratic right over here. Y is equal to 1/2 x squared minus 9/2. And we see that the coefficient on the second degree term, or the highest degree term right over here, is positive. It is 1/2. So this is going to be an upward opening parabola. It's going to look something like that. And when we look at all of these options over here, there's only one upward opening parabola, and that is g of x. So we know that if this has got to be one of these three, this right over here is g of x. So we could say that g of x is equal to 1/2 x squared minus 9/2. Another giveaway that g of x, or that g is being described by y is equal to 1/2 x squared minus 9/2, is you see when x is equal to 0, we have our y-intercept at negative 9/2, which is the same thing as negative 4.5. And you see that is indeed the case for g right over there. It's when x is 0, y is negative 4.5. So we can feel pretty confident about that. Now let's look at these next two. And what I'm going to do, let me try to rewrite them in a neutral color. So we don't use blue yet. So let's think about this one. Y is equal to negative 1/10 times x plus 3 times x squared minus 9. Now we could take the trouble of multiplying all of this stuff out, or we could just think about what is the highest degree term going to look like, and we could also think about what does the lowest degree term look like. What is a constant term? So the highest degree term is going to be negative 1/10 times x squared. So this is going to be y is equal to negative 1/10 x to the third power. Then you're going to have a bunch of other terms in there. You're going to have a bunch of other terms in there. And then you're going to have your lowest, maybe I'll write a plus, although it might be a minus, but then you're going to have a bunch of other terms there. And then you're going to have your lowest degree term, which is going to be negative 9 times 3, which is negative 27, times negative 1/10. Well, that's just going to be positive 27 over 10, which is the same thing as 2.7. Now, just from this, without even knowing all of this business in the middle, we can start to think about what this graph is actually going to look like. First of all, we see it is a third degree polynomial, or it's a third degree expression, I guess we could say, and its coefficient on the third degree term is negative. So that means it's going to have end behavior like negative x to the third. X to the third looks like this. Negative x to the third will look like something like this. So its end behavior is going to look like that. We can think about what it does in the middle. It might jump up and do something like that, but that's what its end behavior is going to be. It has end behavior like negative x to the third. Now, which of these graphs have that type of end behavior? Well, it's pretty clear that h of x, when x is very negative, h of x is positive, just like this. When x is very positive, h of x is very negative. It's the only of these three graphs that have that behavior. So we can feel pretty confident that this is h of x. Now, if we're not sure, we could also look at the y-intercept right over here. When x is equal to 0, all these other terms are 0, and so y is going to be 2.7. And we see that is indeed the case right over here. When x is 0, y is 2.7. So that gives us some confidence as well. Now let's look at this third expression, and obviously we could just deduce that there's only one equation left and one function left, so this has got to be f of x. But let's say we didn't know that. Let's see how we could reason it out. So once again, let's think about multiplying. Figure out what the highest degree term is. Well, the highest degree term is going to be 1/10 times x squared times x squared. So we could rewrite this one as 1/10 x squared times x squared is x to the fourth power. Then we're going to have a bunch of terms, and then our lowest degree term is going to be 9 times 9 times 1/10. That's 81 divided by 10, so that is 8.1. So what type of end behavior is this going to have? You have an even degree polynomial right over here, and it has a positive coefficient. So it's going to have end behavior like a second degree polynomial with a positive coefficient, or it's going to have end behavior like x squared. So it's going to look, when x is really negative, it's going to be really positive. And then when x is really positive, it's going to be really positive. So its end behavior is going to look like that, and it might do some business in between. Well, which of these graphs do that? Well, it's pretty clear that f definitely has that type of end behavior. It does something a little interesting in the middle. And if we wanted to be sure, we could look at this intercept right over here. When x is 0, all these other terms are going to be 0, and you're going to be left just with this y-intercept, which is 8.1. And so when x is 0, we do see indeed that f is sitting here at 8.1. So we can feel pretty confident that that right over there is f of x.